Hello, everyone. So we have 10 a.m. sharp, so we're gonna jump right in today's webinar. First of all, thank you all for attending today. It's gonna be our first very short webinar. So the former webinars were approximately 45 to 1 hour, so we went really deep into the technical topics. Today, it's gonna be more of an overview and a product presentation. So it's a little bit another format. Also, since we use a new format today, I'm very curious how you like this format. If you prefer short webinars, longer webinars, more technical details, less technical details. We will send a feedback form out in the end of our webinar, so you can let us know all the critiques or even compliments that you have if we did a great job. I would love to know both, especially the things that we can do better the next times. All right, let's jump into today's webinar. Today's topic is our newest product. It's the Cala KNX IL CO2. The overall topic is the functions and applications of our new CO2 indicator light. My name is Bastian Elsner, and today I have the pleasure of guiding you through our webinar. Let's start off by our learning goals. So after this webinar, you will be able to determine the indoor air quality, to optimally adjust the parameters of our Cala KNX IL, and how to use the Cala KNX IL in different areas. Let's move on to the agenda. First of all, we start with a very broad product presentation. Next up, the wiring Instagram to show you how we can install the Cala KNX IL. Next up, we will talk a little bit about the theory of CO2 threshold values and how we can control and automate air quality. Next up, we'll have a very quick look into the ETS file. I will just share some screenshots of the ETS application of our newest product. Next up, the part I'm very much looking forward to, it's the application examples and use cases of the newest product. So this is basically what we will discuss in the next 15 to 20 minutes. Let's start off with the product presentation. So the Cala IL CO2 is a CO2 indicator light. So it can indicate the air quality, and it does that via 3 different color levels. Those color levels are displayed here. Also, the device has several functionality integrated. First of all, it has an integrated CO2 threshold values. Next up, integrated CO2 PI control. Also, it contains 4 AND or logic gates. Also, 2 actuating variable comparators can be implemented. Also, we have this product in 2 versions. One with an integrated CO2 sensor and the other one without a CO2 sensor, so a pure light signal. Also, for those 2 variations, we will look into the different application example and different use cases. Also, please remember that we are live today. So if you have any questions, please make use of the question functionality. I would love to make it as interactive as possible. And since we are live, please send all your questions. Also, this product we will have for the Swiss frame size, which is 60 by 60 millimeters. Okay, let's move on to the connection and to the mounting of the Cala KNX IL. So the Cala IL can be integrated into any 55 by 55 millimeter frame program. The device have a connection on the back, so only the KNX bus must be connected. No external power supply needed. Under the number 2, you will find the programming button to set the Cala in the programming mode. Number 3 shows the programming LED. Next up, the Cala is fixed in the support ring by means of the spring clamp in number 4. Also, it's very important to notice that it's not allowed that there's any 230-volt line in the same box or in the neighboring box. To select a mounting location for the Cala KNX IL CO2, where the measurement is distorted as little as possible by external influences. This is very important. One possible source of interference is drafts from windows, doors, or yes, doors and windows mainly. Permanent measured value deviations can be also corrected in the ETS. There's an offset functionality. As shown in this photo, a distance of 4 mm must be maintained to any 230-volt sockets or devices. Let's go into the theory of air quality and CO2 measurement. We found a very interesting graphic, I believe, where you can display the ppm values and what happens to humans if you're exposed to very high ppm values. So the CO2 content on the air affects the general well-being. That much can be said. High CO2 values can cause sleepiness, inattention, reduced concentration, and headaches. Also, it increases the risk of infection diseases. I was quite shocked when I read that fact actually. So especially in the working world, it's very, very important. We need to be concentrated almost all day long. So the perfect air quality is a very important factor also for well-being for employees. We defined the threshold values as following. The indicator light, so this is the values that we set in the product when we manufacture it. So this is basically the basic settings. You can change those settings, of course, but more for that later on. For us, the red light will be triggered when we reach a value of 2000 ppm. Yellow is triggered after 1200 ppm. Green is triggered if we have a value of less than 1200 ppm. This is in line with the official recommendations for indoor air quality usage. Let's have a look into the parameters. Let's start off by the application overview. In the following, we look at the setting of the CO2 indicator light. On the left side, we see all the setting possibilities of the product over the measured values, threshold values, controls, and the logic functions. Most KNX system integrators are familiar with these functions, so I won't go into more detail here. Therefore, I would like to talk you through the setting of the CO2 indicator light and the light signal, because this is something really new. In the first setting, we can define whether the LED panel lighting is switched on or off after programming. Before a value has been communicated via the KNX bus, as well as the brightness in percent. In the setting signal color is determined by, we can select the following. First of all, CO2 total measured value. With this selection, the internally measured CO2 value or the mixed value that can be added by another external sensor is used. Next up, the scene object. Here we have the possibility to switch the LED colors per scene. Third, percent object with threshold value. Here we can toggle the indicator light color by an external percentage value by threshold value. Fourth, a 2-byte floating point object. Here we can switch the indicator light color by an external 2-byte value. Here we see the parameters of the CO2 indicator light when we work with internal CO2, total measured value. We can set whether or not the threshold values and the hysteresis received by the object should be preserved in case of programming and voltage recovery. In the next three settings, we can set a threshold value with which we switch the indicator light color. Here we had already discussed the default values in the last chapter. The threshold values can be also changed externally via a communication object, for example, by a visualization system. In the last three settings, we can specify whether the LED color should be off, permanently, on, or blinking. In the last settings, we still find the output of the status object. We can output the status for each color via a 1-bit object. Alternatively, there is the possibility to output the indicator light color via a 3-byte RGB value. For example, to control further lightening the indicator light. The value for each status can be adjusted individually via the color plate setting. In this application, as in all our new products, we've integrated the context help. So in the red box below, you can see here, you always find information about the selected parameter. How do you find the context help? And do you use it regularly? I would love to know, because for us, it takes a lot of effort to implement the context help, but we believe it's very useful, especially if you have complex products, complex parameters. It really helps customers and especially system integrators to get along with those products. So I'm very curious, is it worth it for us to make this effort and implement it into our entire range? Or you say it's quite obsolete, we don't really need it? I'm very curious about your opinion here. Let's move on to the application examples. So in the last major section, we learned about the parameters of setting the Cala IL. Now we will see how we can use this application and bring it alive into several use cases. Let's start off by the variant with the CO₂ sensor. A very classic application example are offices. As mentioned earlier, the well-being and health, especially the concentration rate of colleagues and employees, are very important. So offices are a prime use case for a device like this. Next up, classrooms, meeting rooms, event location, also kindergartens. Basically everywhere where you have a lot of people and it's important to control the indoor air quality. Next up, some application examples for the Cala IL without the CO₂ sensor. So basically everywhere where a status display is necessary. Very interesting example we will go into more detail is the fill level of tanks. Also the display of window contacts. So for example, if the window is open and it has to be closed because, for example, the alarm system can't be activated if the window is still open, can be a very good indication in each individual office. Hey, please remember, close your door or close the window. Also, the display of error or fault messages. Room occupancy for meeting rooms are also an interesting application example for the Cala IL light signal. Let's go into more detail about the application example of the level indication of a cistern or even a heating oil tank. So the tank probe provides a level measurement from 1 to 100. This value will be changed by the Cala IL. The setting in the Cala IL is therefore, the signal color is determined by percentage object with a threshold value. Threshold value for changing from green to yellow could be 66%, for example. The threshold value for the change from yellow to red could be 33. So you have an indication message very early before your tank is actually running out. What we need for this: the tank probe, level measured value, 0 from 1%, setting in the application of the Cala IL, the Cala KNX IL, the conversion setting, and finally only the setting of the signal color needs to be done, and we're basically done with this application example. Another one is the room occupancy. So the LED display should indicate whether the room is occupied or free. A push button or presence detector in the room provides a scene number. This value is converted accordingly by the Cala IL into the LED display. Accordingly, the setting at the Cala IL is signal color is determined by a scene object with scene numbers for LED off could be 1, scene number for red could be 2, scene number for green could be 3. Next application example, as mentioned a little bit earlier already, is the visualization of window contacts. For example, in our office building, this is the case. If a window is open, for example, in summer, if you want to let some fresh air in, and you forget to close this window, we have an indicator light by every door because we cannot activate our alarm system. This is the case in many buildings, and it's very tedious for a single employee to check all the rooms if the windows are closed, if there's an error message and the alarm system can't be activated. This new product can be of very much help and a lot of time saving also for the facility management. So when the window is open, the LED indicator should flash red. When the window is closed, the LED indicator should be off. A window contact provides a 1-bit signal, a 1-bit signal to the Cala IL. Several windows can be combined using an OR logic. Accordingly, the settings at Cala IL is: signal color is determined by a 3 times 1 bit object. If signal color red is active, the light signal should flash. In a large event location, there are several CO₂ sensors. The mixed value of these sensors should control the CO₂ indicator light. Accordingly, the setting at Cala IL is: signal color is determined by 2 byte floating point objects. The limit value setting for the changeover of the indicator light colors needs to be activated. So from green to yellow, 1200 ppm, yellow to red, 2000 ppm. So I've already came to the end of my presentation. As mentioned in the introductory slides, it's a very short webinar, just a pure overview. We still have a couple minutes left. So I just want to re-inform you that you will receive a feedback form where you can give us feedback for today's webinar. I would very, very much appreciate your feedback, the positive, but also the negative ones, of course. We are still in the beginning stages of our Elsner Academy, and we're learning in each webinar. You can very much help us to improve our webinars. So please tell us what you would like to see, what we can do better next time. Very much interested in that. For the meantime, thank you very much for attending today's webinar. I will stay in the meeting room another couple minutes until 10:25, and then I will close the webinar session. So feel free to ask a couple questions while I'm still here. Thank you very much for your attention, and if we don't talk in the meantime, take care and until next time. Bye bye.